Gas laws describe the correlation between properties of gases. When a change in one property causes a change in another, they are related. If the changes occur in opposite directions, the properties have an inverse relationship. The inverse relationship between the pressure and volume of a gas is known as Boyle's law. What Boyle's law states is that the pressure of a gas is inversely proportional to its volume when the temperature and the amount of gas are kept constant. If the volume or the pressure of the gas sample changes without any change in the temperature or the amount of gas, then the product of the final pressure and the volume is equal to the product of the initial pressure and the volume. So we can put Boyle's law in an equation as P1 V1 is equal to P2 V2. The picture diagrammatically describes what Boyle's law states. The gas sample initially starts with a high volume and a low pressure. When the pressure is increased, its volume goes down. Or when the volume is decreased, its pressure goes up. Throughout this change, the temperature of the sample is kept constant, as well as the number of particles of the gas sample. When a gas is heated, it expands and becomes less dense. This became Charles' law, which states that the volume of a gas is directly related to the temperature when the pressure and the amount of gas are kept constant. A direct relationship is one in which the related properties increase or decrease together. For two conditions, initial and final, we can write Charles' law as the initial volume over the initial temperature is equal to the final volume over the final temperature. If we increase the temperature of a gas, the kinetic energy of the gas particles will also increase. To keep the pressure constant, the volume of the container must increase. If the temperature is decreased, the volume of the container must also decrease to maintain the same pressure when the amount of gas is constant. From the kinetic molecular theory of gases, we know that the gas pressure arises from the collision of gas particles on the wall of the container. We also know that the kinetic energy of the gas particles or the molecules is directly proportional to the temperature. As the temperature of a gas rises, the gas particles would move faster and hit the sides of the container more often and with greater force. If a constant volume and amount of gas is maintained, the pressure will increase. This direct relationship between the pressure and the temperature of a gas is known as Gay-Lussac's law, which states that the pressure of a gas is directly proportional to the Kelvin temperature, as long as the volume and the amount of gas are kept constant. The pressure, volume, and temperature relationships of a gas can be combined in one called the combined gas law, which states that the product of the initial pressure and volume over the initial temperature is equal to the product of the final pressure and volume over the final temperature, as long as the amount of gas is kept constant. This table shows how the combined gas law can be used to derive the previously described gas laws by omitting the properties that are kept unchanged. So when the temperature is kept constant along with the amount of gas, it ends up as Boyle's law. When the pressure is constant, it's Charles' law. And when the volume and the amount of gas are constant, it's Gay-Lussac's law.